In this video, we're going to take a look at how we can go backwards, and if we're given the function, if we're given the value of the function, to figure out what the angle might be, right? So we're going to go through and we're going to take a look at these inverse functions, okay? And they're going to be on your calculator. And what they do is they find the unknown angle of a given value of the trig function. And usually what we're going to do is we're going to use, for instance, the inverse of the sine function is the sine minus 1 on your calculator, or the cos minus 1, or the tan minus 1. Okay, so these are all buttons that we're going to see on our calculators. Okay, and I'm going to use the Desmos calculator. On your graphing calculator, it might be different, but they'll be, or at least it might be in a different location, but at least it'll be the same buttons. We can also use these inverse functions to be able to find values of the trig functions. All right, so we're going to see that in a few moments, how to do that. But first, let's go through and just use a calculator if we're given the value of the trigonometric function to find the angle. All right, so we have the sine of theta equals 0.6546. Another way to think about this is to think that the sine inverse, sine minus 1, of the sine of theta is going to be equal to the sine minus 1 of 0.6546, right? Now, an inverse and a function, for now, is going to cancel each other out. And so we're just left with theta, right? And then what we're going to do in our calculator is two things. First of all, we're going to make sure that we are in the degree mode. Okay, so this is our radian degree mode. In your calculator, you might have to hit the mode button. All right, so you might have to hit mode and then make sure that you're in the degree mode. Okay, so do that first before you do anything else, because we're asked to find the nearest hundredth of a degree. And then from there, what we could do is we could just punch that into our calculator. And so we would type in this sine minus 1 of 0.6546. All right, and just making sure that's the right number, 6546. And then if I go through and hit enter on that, and we can see clearly right away, it's 40.889. Since it would be to the nearest hundredth, it would be 40.89 degrees. Okay, so that's all we have to do. If we're given the trigonometric function, then we just take the inverse. Okay, same thing with a tangent. What I'm going to do is I'm going to take the inverse tangent of tan of both sides of theta, and that's going to be equal to the inverse tan of 0.8643. Inverse tangent cancels out, and so that's going to leave us with theta, and then we're just going to go in our calculator, and we're going to type in inverse tan 8643. All right, so tan minus 1.8643, and that gives us 40.84. All right, did not mean for those to be so close, but it is what it is. Okay, so 40.84 degrees. Right? Now, the last one's a little bit tougher because we don't have an inverse secant on our calculator. Okay, so we have sine, cosine, and tangent. So what we can do is we could just take the reciprocal of both sides to start. And so we would say 1 over cos theta, or sorry, 1 over secant is going to be equal to 1 over 1.5. So this is 1 over the secant of theta is going to be equal to 1 over 1.52765. Right? And remember, the reciprocal of secant is the cosine. And then in our calculator, we could just take the reciprocal of this. So 1 over the 1.52765. Right? So in our calculator, we'll just do 1 over 1.52765. Right? And that'll give us 0.6546. Right? So that's going to be cos of theta is 0.6546. All right. And so then from there, what we can do is now we can find the inverse cosine. Okay. So theta is going to be the inverse cosine of that 0.6546. Okay. So first we just use the reciprocal function. Remember that 1 over secant is cosine. And then in our calculator, we just do the inverse cosine of 6546. All right, so cos minus 1 of 0.6546. and that gives us 49.79. Okay, so this is going to be 49.79 degrees. All right, so hopefully that's pretty easy. If we were to value, if I given the trig function, what the value is to find the angle. Now, one last thing that we're going to be looking at is we're going to find these missing sorts of sides, okay? And one thing to remember is that we have our SOHCAHTOA, okay? So the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And finally, the tan of theta is the opposite over adjacent. And so if we have these, then what we can do is we can just try to relate it. Okay, so let's take a look at what we have here. So we have this angle, 36 degrees. We have an adjacent side. Okay, so notice what we have is we have an angle and adjacent, and we're looking for the opposite. Okay, so this is our adjacent and this is our angle. And we know that a trig function that relates opposite and adjacent is the tangent. And so what we can say is that the tangent of 36 degrees is going to be equal to the opposite, which is A in this case, all right? And then we're going to divide that by the adjacent, which is 50. Now to solve this, what I'm going to do is I'm going to multiply both sides by 50. So I'm going to say 50 tangent of 36 degrees is equal to A. And then what I'm going to do is I'm just going to punch that into my calculator. All right, so I'm going to go ahead, go back to my main functions, and we're going to type in 50 tangents of 36, making sure we're in the degree mode, which we are. So we're going to say 50 tangent, oh, let me clear that out. So 50 tangent of 36 degrees, and that's 36.327. All right, we'll just round it off to 3 decimal places. All right, so that would be 36.327. Technically, it would be in centimeters since that's the unit here, and that would be A. All right. So hopefully that's not too difficult. Okay, so again, all you're doing is you're just seeing what angles you have, like what angle you have, and then also which sides you have relative to what's given. Okay, and then you try to use one of those trig functions to find the rest of everything. So in this example, we have a hypotenuse because it's opposite of the right angle. Okay, so this is a hypotenuse. We have the given angle, and what we don't know is we don't know the adjacent. Okay, so we know if we go back up and look at our relationships, we have adjacent and hypotenuse is equal to the cosine of theta. And so the way that I would set this up is that the cosine of 33 degrees is going to be equal to the adjacent, which is B, divided by the hypotenuse, which is 237. To solve, I'm going to multiply both sides by 237. So we have 237 cos of 33 degrees is equal to B. And then I'm just going to type that into my calculator. All right, so 237 times our cosine of 37 degrees, 33 degrees. And that gives us 198.765. Okay, so that's going to be 198.765 in inches. All right, now, by the way, the hypotenuse is 237. So we know that it shouldn't be any bigger than 237, but it should be in the neighborhood. Okay, if we got something like 5 or maybe 15,000 or something like that, we know that we're wrong. So we should always just think about what our answer should be. Finally, we have this 47 degrees. We have the opposite of that. Okay, so this is our opposite, and then clearly C is our hypotenuse, which we don't know. And so to set this up, remember we have opposite over hypotenuse is going to be the sine. So remember, sine of theta is opposite over hypotenuse. So we're going to have that the sine of 47 degrees is going to be equal to the opposite, which is 22 kilometers, divided by the hypotenuse, which we said was C. Now we have to solve this for C. So what we're going to do first is we're going to multiply both sides by C, and we're going to get C times the sine of 47 degrees equals 22. because the c's would cancel out. Then what I can do is I can divide both sides by the sine of 47 degrees. So C is going to be equal to 22 divided by the sine of 47 degrees. And then we can just go into our calculator, compute that. So 22 divided by the sine of 47. And then we make sure to copy that down right. 22 over sine 47 is going to be 30.081. So that's going to be 30.081 in kilometers. All right. And of course, we need to make sure that that makes some sense. All right. And of course, it does because it should be the longest side. All right. And in this case, 30.081 is certainly bigger than 22. All right. We don't know what this side is, but it should be smaller than 30.081, and we could find it by using the Pythagorean theorem. Okay? So that's everything for this section. Okay, so hopefully this helps out with being able to do some of the more elementary sorts of trigonometric sorts of ideas. The next section, what we're going to do is we're going to move into being able to find the trigonometric values of any angle. All right, so we're basically going to take a step further from some of the things that we've already learned. But before we move on to that, what I'd recommend is that you go back to this section and the previous and make sure you're really solid on those two sections. In fact, the first one as well, 4.1, 4.2, and 4.3. Make sure you're really solid on those before we move on.